So today we're going to learn about empirical formulas. And empirical formulas are the simplest whole number ratio of atoms in a compound. For example, if we had a compound C2H6, the simplest whole number ratio of the elements is 1 to 3, 1 carbon to 3 hydrogens. We would divide each of them by 2, and that's the empirical formula. It's not the actual formula. If we look at something like hydrogen peroxide, H2O2, the simplest whole number ratio is 1 to 1, so H and O, because there's one H for every oxygen, even though our formula is H2O2. That's the molecular formula and what we're going to work on the next day. So the steps that we need to take to do these calculations are, first we need to obtain the mass of each element present, and that's typically what's given to us in the problem. We also need to determine the number of moles of each type of atom present. And so we're going to convert those grams to moles, just like we've learned how to do. We're going to divide the number of moles of each element by the smallest number of moles to convert the smallest number to 1, because we're going to end up with decimal ratios, and that's not really going to help us. This step will make a lot more sense when we see the sample problems. And finally, if we're needed, we're going to multiply the numbers we derive by the smallest integer that will convert all of them to whole numbers. Sometimes we get a ratio of like 1 to 1.5, and in that case we don't have 1.5 of any element. We need to have whole numbers. This set of whole numbers will represent the subscripts in the empirical formula. So here's our first problem. An oxide of aluminum is formed by the reaction of 4.151 grams of aluminum with 3.692 grams of oxygen. Calculate the empirical formula. So we're going to start with our grams. 4.151 grams aluminum and 3.692 grams of oxygen. We're going to convert both of them to moles. We're going to put grams on the bottom and moles on the top. 1 mole is equal to 26.98 grams of aluminum. And when I do that problem, I get 0.154 moles of aluminum. Then I'm going to convert my oxygen. So I have grams of oxygen on the bottom, moles of oxygen on the top. I know I can only put 1 in for moles. I'm going to put 16.00. This is the one time when we do empirical formulas that we're not going to treat oxygen as diatomic. We need moles of oxygen atoms, not molecules. So in this case, we're not going to use that diatomic rule. It equals 0.231 moles of oxygen. Now, here's that dividing step. We have a ratio of 0.154 to 0.231, but that doesn't help us write a formula. So we're going to divide through by our smallest number, which is 0.154. So this ends up being 1, and this ends up being 1.5. We round these to semi-whole numbers. Now, I don't have 1.5 of an oxygen atom, which means I need to go through and double everything. So I end up with 2 aluminums and 3 oxygens. Means my formula is Al2O3. This makes sense in what we've learned with formula writing. Al is a +3 charge, O is a -2 charge. So now, when we look at another sample, we have a 0.3546 gram sample of vanadium is heated in air and it's reacting with oxygen to receive a final volume of 0.6330. Calculate the empirical formula of this compound. Well, I have my sample of vanadium, 0.3546 grams of vanadium, but I don't have my grams of oxygen. I have a total. So I'm going to need to subtract. I'm going to need to take the 0.6330 grams, which is the total, subtract the 0.3546 grams, that was the vanadium, and end up with 0.2784 grams. That's going to be my grams of oxygen. 0.2784 grams of oxygen. Again, grams goes on the bottom, moles. Okay, sorry about that. So we have grams of vanadium, we have moles of vanadium, we have 1 mole of vanadium, and that weighs 50.94. And when I convert that to moles, I end up with 0.00696 moles of vanadium. Oxygen, again, I'm going to put grams of oxygen on the bottom, moles of oxygen on top, 1 mole of oxygen, 16 grams of oxygen and get 0.0174 moles of oxygen. I'm going to divide through by my smallest number, which is the 0.00696. Here I end up with 1, and here I end up with 2.5. Again, I can't have 2.5 oxygens, so I'm going to multiply everything by 2. I end up with 2, and I end up with 5, and so my formula is V2O5. In this one, the problem is a little bit different. It's given to us in percentages. But percentage by mass, if we have 74.5% lead by mass, so it says in a lab experiment, we observed that a sample made of lead combines with chlorine to form a binary compound. It's just the two of them together. Calculate the empirical formula. The compound is 74.50% lead by mass and 25.50% chlorine by mass. Well, it's given in percentages, but let's just assume we have 100 grams. If I have 100 grams total, 74.5% of it is lead. So I'm going to have 74.50 grams of lead. And again, I'm going to convert it to moles, grams of Pb, moles of Pb, 1 mole, and that weighs 207.2. And I'm going to have 25.50 grams of chlorine, because if I assume that 100 grams, that's how that's going to work out. So I'm going to have grams of chlorine on the bottom, moles of chlorine on top, 1 mole, 35.45. I solve this, and I get 0.3596 moles of Pb, and I get 0.7193 moles of Cl. I divide through by my 0.3596, 0.3596, and here I get 1, and here I get 2, and I get PbCl2. Again, I'm always checking to make sure my formulas make somewhat sense. And then here in my last problem, I actually have 4 things, okay? I have 1.3813 grams of lead, 0.00672 grams of hydrogen, 0.4995 grams of arsenic, and 0.4267 grams of oxygen. There's nothing different. I'm going to do the same steps, but I have 4 different substances to do it for. I didn't really save myself much room on the bottom here, so I'm going to start my problem actually up here. So I have the 1.3813 grams of Pb, and I have, again, grams of Pb on the bottom, moles of Pb on the top. 1 mole is equal to 207.2 grams, and when I convert that to moles, I get 0.0066665. I'm keeping 4 significant figures, moles of Pb. I also have 0.00672 grams of hydrogen. If I multiply that, 1 mole of hydrogen, again we're not using Hunkelbriefs, 1.01 grams of hydrogen, I end up with 0.00663 moles of hydrogen. I come down here, I have 0.4995 grams of arsenic times, getting rid of my grams of arsenic, converting to moles of arsenic, 1 mole, 74.92, and I get 0.00667 moles of arsenic. Oops, AS there. And then I have 0.4267 grams of oxygen. Getting rid of my grams of oxygen, moles of oxygen, 1 mole of oxygen is equal to 16 grams of oxygen, and I end up with 0.02667 moles of oxygen. I know that these 3 are very close. I mean, I'll pick the smallest one. So it's the 6653, so divide by 0.006653, divided by 0.006653, divided by 0.006653, divided by 0.006653, and obviously I end up with 1, 1, 1, and 4. So in this case, we're just going to put it in the order that we did the problem. We have PB, H, AS, O, 4 is our final answer. I know some of these you might not be able to know what order the elements goes in.
Just a reminder for all faculty to go to the auditorium. Thank you.
And since I couldn't stop that in time, I'm sorry there's announcements in this, but that is the end of our problems for today. Thanks.